All right, the last conics section that we're going to talk about are parabolas. Now we're going to learn all. We're still going to review all the things that we did before when we did parabolas. However, we're going to add some new features to parabolas as well. First of all, let's talk about the definition of a parabola. Y is equal to x squared. That's a parabola, Smith. Well, here's the thing. The technical definition of a parabola is the set of points such that each point is equidistant from a fixed point called the focus and a line called the, Matt's got the coolest words, check this out, Directrix. So here's what's up. We've seen parabolas. We know what parabolas look like, right? They look like that, kinda. Alright, so here's what's up. There's a focus, and in every other shape that we've done, hyperbolas, ellipses, the focus has been inside the curve. No difference here. The focus is inside a parabola. Now, the directrix is going to be directly behind the parabola. Yikes. This here is called the directrix. And it says a parabola is a set of all points where each point is equidistant from the focus. So this green point here, the distance from here to here is equal to the distance from here to here, even though it doesn't look like it. Why would it, Smith? You drew it. Anyways, or even this point here, the distance from this point to the focus is the same as this point to the directrix. All right, every point, even here, would be like that. All right, every point is equidistant from the point and the directrix. Now, both the focus and the directrix are p units from the vertex. What is p, Smith? Well, here's the thing. P is 4 times p is equal to the reciprocal of a. All right, and that's back from our vertex form. All right, or standard form, or anything when we were doing parabolas, a. Now, let's talk about the tools that we're going to need. First thing we need is the graphing form. Now, there's going to be two different graphing forms. The first one is what you know. Y is equal to A times the quantity of x minus h quantity squared plus k. We know and love this one, right? This one opens up. Actually, it opens up or down, depending on what A is, right? If A is positive, it opens up. If A is negative, it opens down. The axis of symmetry is x equals to whatever the x coordinate was, right? And the vertex is at h comma k. All right? But then there's a new one. The new one is x equals a times the quantity of y minus k quantity squared plus, you guessed it, h. All right? Slightly different, right? X and y got changed. Even the h's and k's got changed. Here's what's up with this one. This one opens left or right. Now, if A is positive, it's going to open to the right in the positive direction. If A is negative, it's going to open to the left in the negative direction. The axis of symmetry. Now, because it opens left and right, the axis of symmetry is something like this, right? It's a horizontal line. So the horizontal line is always y is equal to something. And the vertex here, the vertex is going to be h comma k. All right, now be careful. In this case, k is the opposite of what you think, and h is what it's supposed to be. All right, so the other tools that we're going to need our graphing form. We're going to need to complete the square. Let me get a different color here. That's not really that different, is it? Anyways, complete the square. You're going to need to find the x-intercepts. Now, what are the coordinates of any x-intercepts? Something, comma, 0. The y-intercept is 0, comma, something. Right? And the other thing that we're going to need is the quadratic formula. Quadratic formula is x is equal to opposite b plus or minus the square root of b squared minus 4ac all divided by 2a. Now, if you don't like the quadratic formula, that's fine. What is a tool that we can use that is comparable to the quadratic formula? The comparable tool would be solving by completing the square. All right? Quadratic formula and solving by completing the square do the same job. It's just, I think you're going to start liking the quadratic formula a little bit better for these. All right, so let's do an example. Our first example is going to be example x equals negative 2y squared plus 12y minus 10. All right, so lately we have been doing a lot of circles, hyperbolas, and ellipses, and all three of those have two squared terms, right? We had an x squared and a y squared. Here, there's only one squared term. All right, that's going to be your clue that this is a parabola. If there's only one thing that's squared, it's a parabola. Now, in this case, I did some of the work for you. This is going to be an x equals parabola, but we still got to go and complete the square. So go ahead and complete the square. Actually, I'm just going to fast forward. If you need help, press pause and do it. But your final answer should be x equals negative 2 times the quantity of y minus 3, quantity squared, plus 8. Here's our graphing form. This is what we are dealing with. All right. Because this is x is equal to, this is a sideways parabola. All right. So our vertex is the point. Now remember, this is h and this is k. So this is the point 8. It's the opposite of what you think for k here. 8, 3. Our vertex is at 8, 3. Which way does this open? This opens to the, now because it's x equals to, it's left or right, but a is negative. So that means it opens to the left. What's our shape here? Our shape, same rules apply. If a is equal, if the absolute value of a is equal to 1, it's normal. Bigger than 1 does more work, so it's skinny. Less than 1 does less work, so it's wide. In this case, the absolute value of negative 2 is 2, does more work, so it is narrow. This one is narrow. All right, let's talk about the x-intercepts. X-intercept is the point something, comma, 0. In other words, y is 0. So let's plug in 0 for y. Now, when you plug in 0 for y, that's nice. It's really easy. 0 minus 3 is negative 3. Squared is 9. 9 times negative 2 is negative 18. Plus 8 is negative 10. So our x-intercept here is negative 10. Our y-intercepts is a little bit more complicated. It's going to be 0, comma, something. Now, before I go ahead and make a graph of this, I am going to make a little sketch. Our vertex is at 8, 3, and we know that it opens to the left like this. So here's the thing. How many x-intercepts does this have? This has 1, right? It only is going to cross the x-axis. Now, where my sketch is nowhere near where it actually is. But we can see that there's going to be 1 no matter where it's at. Y in intercepts, there are 2 of them. So plug in 0 for x, and what you got here is 0. 0 equals negative 2 times the quantity of y minus 3 quantity squared plus 8. All right, so we solve for y. In this case, it's nice because we can just solve by moving stuff. So we got negative 8 equals negative 2 y minus 3 quantity squared. Divide by negative 2, you get 4 equals y minus 3 quantity squared. Square root, you get plus or minus 2 equals y minus 3. Add 3 to both sides, so you got 3 plus or minus 2 is equal to y. So that means that y is 5 or 1. Those are our 2 y-intercepts. So our y-intercepts occur at 0, 5 and at 0, 1. All right. The other one that's easy is the axis of symmetry. The axis of symmetry, because this is opens left and right, the axis of symmetry is a horizontal line, so it's y equals, and it's going to be the y-coordinate of the vertex. Y is equal to 3. Okay, before we go further, and there is more to do, don't worry about that. Let's graph this really quick. So our vertex is at 8, 3. Our x-intercept is negative 10, 0. So right there. Our y-intercepts are at 0, 1 and at 0, 5. So right away I got a nice little sketch of my graph. I bet this is somewhere up here, right? This is going to be narrow, so this goes like this. This loops around, goes like this. This is a sideways opening parabola, where this is our vertex, x-intercepts, y-intercept. All right. Next thing we need to find are directrix and focus. Now remember, focus is somewhere inside. The directrix is going to be a line behind the parabola, so that it's kind of like, well, I don't know what I was trying to say there. So let's find P. Now, if you recall, 4P equals the reciprocal of A. Now, in this case, A is negative 2. So 4P is equal to negative 1/2, the reciprocal of A. So that means that P is negative 1/8. Okay, so remember, our center is the point, or excuse me, vertex. Vertex is the point 8, 3. All right. Our focus is going to be 1/8 of a unit inside the parabola. So here's what's up. It's 1/8 of a unit inside of here. Here's our focus. Now, what changed? Did the y-coordinate change? No. Right? The y-coordinate's still up here at 3. What happened was the x-coordinate changed. It went up or down. It went down 1/8 of a unit. Now, you guys know how much I hate mixed numbers. However, I'll let you use it here. So, this was 8. It went down 1/8 of a unit. So, our focus is at 7 7/8, comma 3. That didn't change. Now, the directrix is an equation. The directrix is 1/8 of a unit behind the parabola, like this. All right? It's kind of like perpendicular to a parabola, which doesn't make any sense, but maybe you know what I'm talking about. This here is the parabola. So, since it's a vertical line, the equation is x equals, now, because it was 1/8 on the other side of 8, x is equal to 8 and 1/8. That is our directrix. All right, bring your questions. I'm sure you got plenty. Smith out.